Hello everyone, it's Miss Russell, and I want to do a pre-lab discussion on the melting point of paradichlorobenzene. Okay, so everybody can see my screen here, and I have right here with me this chemical. We'll take a look at it. It's paradichlorobenzene. I'm going to tell you all about that. You see, it's a solid crystal at room temperature. And this is what we're going to determine the melting point of. So in our introduction to chemistry lesson, we're going to learn about some physical properties. And melting point is a physical property. So melting point, boiling point, these are physical properties. And every substance has a melting point, a boiling point, it has a specific density. Density is another physical property. So this is a fantastic lab to get you into learning the basics of chemistry and the basics of going to lab, using lab equipment, and learning how to light a Bunsen burner, how to read a thermometer, how to boil some water with some lab equipment. So I'm going to do this lecture here for you. And then in the classroom, I'm going to show you how to do the lab setup, okay? And we'll also take a picture of that and post it on the Google Classroom so that you can see it. Okay, so this lab is called the melting point of paradichlorobenzene, and it is in your Google Classroom. It's under materials, and I've also got it posted under lab experiments. So this will be the first of many labs that we do in honors physical science. So this chemical looks like this. This is its structure here. And this is how we draw it. And we've got this right here is called a benzene ring. And you'll learn more about that in the next course. And it's got these chlorines on here. If you've been studying your elements, you know that that is the element chlorine. And it's written 1,4-dichlorobenzene. It can have that name, or it can be called paradichlorobenzene. Make sure this is, yes. Make sure I'm recording. I hope so. One second. So while I'm messing with this, you all should be, yes, it's recording. You all should be taking notes on this. So take notes. Now, let me tell you something about science. We love to have about 4 different names for everything. So this is the 2 names of this compound here. Let me show you something. See this 1 and 4? This shows me the locations of these chlorines here. So it's on the first carbon, and these are carbon tips here. Every tip here is a carbon compound. And I'm gonna draw it in a different way for you in a minute, just for the heck of it. So this shows me the location of the carbons. Now you notice this right here, di. What does di mean? It means poo. So it's saying that there's 2 chlorines on this benzene ring. That is pretty cool, isn't it? So we like to be lazy, don't we? So this right here, this structure is so much easier to draw than what I'm about to draw for you. So this is what it looks like. Got these Carbons attached like this. Done a terrible job of drawing this. And it has these alternating single double bonds. So that's single double, single double, single double. Okay, so this shape is supposed to look like this, forgive me. And then I'm going to stick in the chlorines here. And then it's actually, some of these have some hydrogen sticking off. So that's 1, 2, 3, 4. And then I've got another hydrogen here. No hydrogens here. One hydrogen here. One hydrogen here. Okay, and that is what it looks like here. That's complicated, isn't it? And this is a lot simpler. So scientists, or chemists rather, they take this and draw it like this. And this is the universal symbol for benzene. So paradichlorobenzene is a substance with a benzene ring on it. Okay? So 1, 2, 3, 4. That's the fourth carbon. See this right here? 1 carbon, 2, 3, and 4. So it's 1,4-dichlorobenzene or paradichlorobenzene. So para means 1,4. And then there's also other placement ones. Meta, I believe it's 1,3, and ortho is 2,3, I believe, but that's not important. Okay, so this substance here is a great chemical to use in the high school chemistry lab because it has a low melting point. So we use, let's see if I can't fix this a little. We use PDB for our melting point lab. Because it has a low melting point. And you can look that up on the internet. You can look it up on Google. What is the melting point for paradichlorobenzene? Or I can show you this big giant book that I have in my classroom, and it's called the Handbook of Chemistry and Physics. And you can find all sorts of information about every compound known in the world in that book, or you can Google it. So the melting point, and write this down, you should have some notes, of PDB is 53.1 degrees Celsius. And this is a low number, relatively low number. And that's why we use this compound in this particular lab, because we can actually achieve that in a high school chemistry lab. And like an ionic compound, salt, we cannot use that because we cannot get salt to melt in our lab. Now, PDB is an organic compound, and you probably learned this in biology. Organic compound compounds contain what? What element is their basis? Would you say? Yes, that's right, carbon. So organic compounds are carbon-based. You saw the carbons that I drew back here? Look at this. Look at the carbons here. 1, 2, 3, 4, 5, 6 carbons here in this chain. So this is the cycle chain there. So organic compounds are carbon-based. Now, I'm not going to tell you right here today what this is commonly used for. We're going to fill it in the blank in the classroom. PDB is commonly used for blank. Believe it or not, you probably come in contact with this compound every single day of your life. And we're going to pass around some samples, or because of COVID protocols, I'll probably put some samples on your desk there, depending on how many people's in the classroom. And I'm going to let you this stuff. It smells so good. It's one of my favorite smells. You may not think so, but I think so. So anyway, we'll fill this in later. I can smell it here. Whoops. This right here is a test tube holder, test tube holder. That's part of your equipment. And you see how I did it here with my test tube. I'm holding on to the test tube. It's not a test tube clamp. That's something else that attaches to a ring stand. That's a test tube holder. Okay, so what you're going to do in this lab is you are going to take this solid and turn it into a liquid. And you're going to put a thermometer down in here, and then you're going to cool it off and make it form a solid again. So when you do that, you're going to graph time and temperature. So you're going to do this every 30 seconds. So this is the cooling behavior, because you're going to have it hot. You're going to melt this. You don't follow the instructions on the lab handout. You're going to melt this, and then you're going to stick a thermometer in here, and you're going to start reading. Somebody's going to time, and then somebody's going to take the temperature. That's how we usually do it. Now, you may have to do this alone, by yourself. I don't know. We haven't worked out all those protocols yet, but this is typically how we do it. We have somebody reading the temperature on the thermometer, and you can do it by yourself, and then taking the time every 30 seconds. So at 0, you will write down what the temperature is. And then at 30 seconds, you're going to write down what the temperature is. And then at 60 seconds, you're going to write down what the temperature is. So let's just do it. We're going to be having to graph it in minutes, because we're going to take down so much data, it won't fit on a graph. So we're going to go ahead and put this in minutes. I'll just save you a little time. 1 minute, 1.5 minutes, and you'll do the temperature. Then at 2 minutes, you'll do the temperature. And then at 2.5 minutes, you'll do the temperature. So you can use your phones and put your timer on for every 30 seconds for your alarm to go off, or you could simply use the clock on the wall. Okay, so you're also going to write down some observations. So this right here would be a complete liquid at this point, and then over time, what's going to happen as it cools off? It's going to become a solid. So at the end of this data table, you're going to have a thermometer stuck in here, and you do not want to pull that thermometer out. Can you imagine that? A thermometer stuck down here, and this has crystallized or solidified around the thermometer. So if you try to yank the thermometer out, it's going to break the thermometer. So let's not do that. So you're going to get it out in the next step anyway. So the next step is called warming behavior. And you're going to do the same thing. You're going to do time, you're going to do temperature, and you're going to write down a few observations. And you don't have, most of the time they're going to be the same, so you don't have to write them observations every single time, but when you start seeing a change, definitely write that change. So we're going to start all over again. We're going to start at 0, and we're going to record the temperature, whatever it is. And here it's going to be a solid for sure. So we're going to, if we're going to warm it up, we're going to change it from a solid back into a liquid. So down here at the end, you will have a liquid at however many minutes that is. And it is tedious, it takes time. You're reading that thermometer every 30 seconds, and sometimes you don't get any temperature changes. You just write that same temperature down. If it's 10 times you've got the same temperature, that's perfectly okay. But you guys get real impatient, you want to see a change, well, it will happen. Now, in the meantime, for this to happen, you've used some boiling water, or not quite boiling. You've gotten it hot. You do not want it totally boiling. Again, follow the directions on the lab handout. So the point is that what you're going to do is you're going to collect this data, and then when you're finished, you're going to clean up everything, and then you're going to make a graph. All right, so we're going to graph time versus temperature. And every graph has a title. You got to make sure you put the title, the melting point of PDB. And you're going to make this nice and neat. We're going to do like a draft first. We're going to do a first run of this so you can get the hang of it. And then you're going to have a nice, pretty one in your lab notebook. Okay. And that's going to be a whole nother discussion on how to set that lab notebook up. But we're not worried about that right now. We're worried about getting ready for this lab and what to do and how to do it. And like I told you, I'm also going to show you this to you in class, but I wanted to go ahead and do this part where you can take the notes down here on this particular lesson that I'm recording. Okay, so I've got temperature, and that's going to be in degrees Celsius. So my axes have to be labeled. I have my temperature and I have the units, and then here I have time, and I'm going to put that in minutes. So I'm going to have like 0.5. 1.0, 1.5, 2, 2.5, etc. And then I'm going to have whatever my temperature scale is over here. So I'm going to end up getting a graph that looks something like this. And again, I'm going to talk to you about that more. So this would be what's going on here. I started off with a high temperature and I went to a lower temperature. So that's going to be my cooling behavior. So I want to make a legend here. And then let's do another color. This looks similar. Let's get color. Get this blue, a bright blue. And then I want to do something like this. So that would be warming behavior. So that's the parts of my graph here. So what we're going to do is we're going to look right here. All right, I got a red one. And this point where it intersects, that is going to be your melting point. Okay, I'm going to do this again with you. I just wanted to do this pre-lab discussion on what we're going to be doing with this lab and giving you some information about paradichlorobenzene. Now, another thing that we're going to learn how to do here in this lab is a percent error calculation. Percent error. Now, you'll need to memorize this formula because you're going to use it so many times in my class. So the percent error is the accepted value or the known value minus the experimental value. And you take the absolute value of that, because if it's negative, you can just get rid of it. And you're going to divide that by the accepted value. And then you're going to multiply by 100. So you need to know this formula. You're going to use it over and over and over again. This will be on a quiz, and you have to write this formula. So the accepted value, this is the value that if you Googled the melting point of PDB, it would tell you 53.1. That's the accepted value. That's the value you're going to get out of that handbook of chemistry and physics. And that's the melting point, the boiling point, the density value, whatever. That's the known value. This right here, this is the experimental value. I'm going to rewrite this equation for you. The experimental value is what you get in your lab. You divide that by the accepted value and multiply it by 100, and tells you how far off you are percentage-wise from that accepted value. So I'm just going to abbreviate this. The accepted value minus the experimental value over the accepted value, take the absolute value of that, multiply by 100. That looks better. So accepted value is the known value. Experimental value, that is what you get. So let's just say we did this lab and I know this, 53.1, and me and my group, we got 52.0. Okay. So let's see how far off I am. I'm going to take that, multiply by 100. Okay, so I'm going to get my calculator out. And I'm going to say 53.1 minus 52 equals, divide by 53.1 times 100. And I get a 2.07% error. So you're just going to give me two places after the decimal here. 2.07% error. That is fantastic for a high school lab, the results. And I just made those numbers up, but people do get really great results on this lab. Some people get bad results, but typically the results are pretty good. It is what it is, right? Because we don't have time to go back in and you said, oh no, I had a 30% error. Well, you just had a 30% error. You're not going to get an F because of that. You're going to document what you got because that's what we do. We don't have time to go back and run the lab again. So that is pretty much what I wanted to talk to you about for this lab. Let me check my notes. And we will go back through this and we'll go through this discussion. Again, I'll show you the lab setup and I'll show you the technique for putting the thermometer in there and how to set up everything, because it's your first time and it's really important that you develop some of these lab skills in this particular lab. So thanks for listening, and we'll go over this in class pretty soon.